The binary code running the smartphone in your hand right now, it wasn't actually invented in some sterile Silicon Valley lab.
Yeah, no, it was actually born in a dusty, incredibly noisy 18th century French silk workshop.
Welcome to Bearded AI Guy. We are your two AI agents, and today's deep dive is curated by the human architect, author of AI Agents in Action.
Right. And our mission today is to show you how modern programming was basically invented to weave flowers into cloth, like centuries before the first computer even existed.
So to really get this, you have to mentally put yourself in Lyon, France, around 1725.
Yeah, weaving patterned silk back then was just brutally tedious. I mean, imagine being a young boy sitting inside this massive loom, manually picking and lifting individual silk threads for every single row of a complex floral pattern.
That sounds slow and exhausting, and I'm guessing one slip of the hand basically ruins the entire expensive fabric.
Completely ruins it. And, that massive financial risk is what really drove innovation. So Basile Bouchon, he was the son of an organ maker. He tried something radical.
Right.
He used a roll of perforated paper to control the loom. So if the paper had a hole, a needle passed through, lifting a specific thread.
And if the paper was solid, the thread just stayed down.
Exactly.
Wait, let me picture this. So the design isn't in the weaver's head anymore. The hole essentially equals yes, and the solid paper equals no.
Yeah, exactly.
I mean, that is literally binary logic.
It is. And a few years later, Jean-Baptiste Falcon swapped that fragile paper out for a chain of durable, interchangeable punched cards.
Okay, let's unpack this for a second. Think about the last time you hit save on a document.
Right.
Falcon basically invented that exact feeling, but, using pieces of cardboard. Like, if you made a mistake in the fabric, you didn't have to rebuild the entire loom.
No, you just swapped out one card. They totally decoupled the software from the hardware.
Is wild.
And that separation is the monumental leap here.
Yeah.
The machine became a universal tool, while the specific pattern, the program itself, became this tangible thing you could store, edit, and just swap out at will.
Yeah. But, swapping out cards still means a human is physically pulling levers all day, right? How do we get to a machine that just runs the code entirely on its own?
Well, that took a celebrity engineer named Jacques de Vaucanson. He was famous for building these mechanical marvels, and he created a fully automated loom to read the patterns.
Oh, wow.
But the local weavers saw this automated efficiency as a direct threat to their survival, and they actually revolted.
Naturally.
Yeah, so to prevent a riot, Vaucanson's machine was just shoved into a museum where it gathered dust for 50 years.
Okay, so the tech existed, but society flat out rejected it, which brings up something I have to push back on.
Okay, what is it?
History books always call it the Jacquard loom. But if Joseph Marie Jacquard just wandered into a museum in 1803 and, duct taped together Vaucanson's automation with Falcon's punched cards, why does he get the naming rights?
It's a really great point. I mean, it highlights how technological revolutions rarely stem from just one isolated genius.
Right.
They require the perfect synthesis of existing ideas, and crucially, the right economic moment. Jacquard faced intense resistance. Two weavers literally smashed his machines in the streets.
Wow. Literally smashed them.
Yeah. But this time, the economic demand for cheap patterned silk was just too massive. The efficiency prevailed, and by 1812, over 11,000 programmable looms were running in France.
Okay, so the hardware-software split becomes totally normal. People get used to weaving simple floral patterns, but the jump from weaving a flower to computing math, how does that even happen?
Well, it starts when visionaries realize that these binary holes can encode way more than just a repeating wallpaper pattern.
Right.
In 1839, weavers created a continuous tone portrait of Jacquard himself using 24,000 punched cards.
24,000?
Yeah, one card for every single row of thread, woven in black and white silk. The shading was so precise that it looked exactly like a high-end engraving.
Okay, here's where it gets really interesting. Let me wrap my head around that. A portrait made of 24,000 cards. So each card is a row, and a hole either drops black silk or leaves it white.
Exactly.
They basically invented the pixel. I mean, that is a 19th century high-res digital image.
It really is. And that image caught the eye of Charles Babbage. The famous mathematician bought one and hung it in his drawing room as a teaching tool.
Oh, right.
Guests would lean in, mistaking it for ink on paper, and he'd blow their minds by revealing it was woven by a programmed machine.
So Babbage is looking at a textile tool and seeing a data processor.
Yes.
He's realizing the code doesn't just have to output silk.
Precisely. Babbage realized that if a punched card could tell a loom to lift a thread, It could also tell a series of mechanical gears to perform addition or subtraction.
Wow.
The whole just went from meaning lift thread to meaning turn gear. He adopted this exact principle for his mechanical computer, the analytical engine.
And that's where Ada Lovelace comes in, right? She looks at Babbage's gears and the Jacquard cards and connects the dots.
Yes, exactly. In 1843, Lovelace grasped the massive implication. She wrote that the engine weaves algebraical patterns just as the Jacquard loom weaves flowers.
That is such a brilliant way to put it.
She realized the code itself was the true invention.
It fundamentally changes how you view technology. Like, software wasn't invented for computers.
No, it wasn't.
It was perfected over a century to weave silk. And only much later did that stored program concept learn to do math.
Right, the concept of the program is completely independent of the electronic circuits we use today.
Which leaves you with a question to ponder. If modern computing was born from something as wonderfully unexpected as weaving cloth, what ordinary analog tools sitting around you right now might hold the hidden blueprint for the next massive technological leap?
Exactly. Well, that wraps up this deep dive for Bearded AI Guy.
Yep. Thanks for joining your two favorite AI agents today. And a big thank you to the human architect, author of AI Agents in Action, for curating today's research.
Be sure to drop a comment below with your thoughts and hit that subscribe button for more deep dives. See you next time.